Hello everyone. In this tutorial, I'm going to introduce the Unroll command in Rhino 3D. This is a great command for transforming some 3D volumes into 2D parts prepared for folding type assemblies. Please note that this tutorial is aimed at preparing objects for folding without consideration for thickness, which means this workflow is limited to thin materials such as Bristol, copy paper, thin plastics, vinyl, etc. In tutorial 3, I will review the extra steps that should be considered when preparing thicker materials for folding assemblies, such as chipboard, museum board, and things of that nature. So first, let's check the units by typing in units into the command bar. We want to be in inches, and we want our model precision to match that of the laser cutter, which is about 1/32 of an inch. Over in the layers panel, let's create 3 layers: build, cut, and etch. Leave built as the default color black. Change cut to blue or R equals 0, G equals 0, B equals 255. Change etch to magenta or R equals 255, G equals 0, B equals 255. Remember, it is important to select colors that the laser cutter will be able to register, which includes these colors. So to introduce the concept of the unroll command, we will start with a very simple shape, such as a cube. Type box into the command bar to begin the box command. Type in 0 to start your box at the origin, and then type in 6, enter 6, enter 6, so that we can construct a 6-inch cube. Select your newly constructed cube and begin the unroll command. Pay attention to these settings up here. We will want to make sure explode is set to no and labels are also set to no. I will show you what these commands do in just a second. Press the space bar. Now we see our unrolled surface somewhere near the origin. We may need to move our original cube with the gumball tool so that we can better see the pieces. Okay, let me show you what would happen if we enabled the other settings. Move the unrolled cube surfaces to the side. Select your constructed cube again and begin the unroll command. This time set explode to yes and press the space bar. You will see that all of the faces have separated and relational edges have been lost. For the purpose of folding assemblies, we want to keep the relational edges so that the pieces can fold back into the volume that we originally created. So undo that unroll, select the constructed cube and begin the unroll command again. This time, set explode to no and labels to yes. Press the space bar. All the numbers on the pieces now correspond to the numbers on the 3D volume. You can use the ungroup command to separate the text dots from the surfaces. You can probably imagine how this will be a helpful option when dealing with more complicated poly surfaces, as you're trying to figure out how to fold the object back into its 3D geometry. So going back to our first unroll result, we now want to turn this surface into line work that can be sent to the laser cutter. In order to pull out the folding lines, we need to unjoin the unrolled polysurface using the explode command. Orbit while holding Control-Shift and orient to the top view. Select all of the unrolled surfaces from our cube and begin the Make 2D command. Now this unrolled polysurface has changed to line work. Select all of the line work, right-click on the cut layer, and change the lines to this cut layer. Press Escape to clear your selection. Now select all the interior lines and right-click on the etch layer and change these selected objects to that layer. The assigned cut lines will cut the perimeter of the pieces to remove the piece from the material, while the etch lines will provide score marks that will aid with folding and assembly. Now let's try this exercise with a few different volumes. Here I have a pyramid, a gabled volume, and a cylinder. Select the pyramid and begin the unroll command, making sure that explode and labels both equal no. Orient to the top and explode the surface. Use the Make 2D command to change the poly surface to line work, change the perimeter lines to the cut layer, and the interior lines to the etch layer. Select the gabled volume and begin the unroll command, making sure that explode and labels both equal no. Orient to the top and explode the poly surface. Use the Make 2D command to change the poly surface to line work. Change the perimeter lines to the cut layer and the interior lines to the etch layer. Select the cylinder and begin the Unroll command, making sure that Explode and Labels both equal no. Orient to the top and explode the poly surface. Use the Make 2D command to change the poly surface to line work. Let's go ahead and change all of these lines to the cut layer. For curved surfaces, depending on the material you choose and the scale of your model, it might be useful to draw in some additional score lines on the etch layer at equal distances. We can do this using the Array Curve command, which will array an object along a specified curve. So begin the Array Curve command. Select the leftmost vertical edge of the cylinder as the object to array and press the spacebar. Select this bottom horizontal curve as the path curve. So something to be aware of is that if you choose to specify the distance between the objects rather than the number of objects, they will not be spaced evenly. The remainder of the subdivision will be consequential to the line length. We can test that out by typing 5 inches as the distance between objects, and you can see that the right piece is not of equal area to the rest of the pieces. So undo this and then run the Array Curve command again, selecting the vertical curve as the object to be arrayed and the horizontal curve as the path curve. Let's type in 18 as the number of objects we want to array, which will evenly space them at about an inch. Set the orientation to no rotation and press OK. Change these newly arrayed lines to the etch layer. In the next tutorial, I will introduce some tips for working with more complicated poly surfaces and what to do if the Unroll command doesn't work for your object.